Hello and welcome. In this video, we will going to walk you through the data presentation phase and how to build the machine learning models using Python. We will cover essential steps like cleaning, transforming, and structuring your data. Then dive into building powerful models using decision trees and random forest. Let's get started. Before you start building any machine learning model or data needs to be ready. This is where the data presentation phase come in. It's like just getting the ingredients ready before cooking. You need to clean, organize data for the best result. First, cleaning the data. This means fixing inconsistencies, handling missing values, and removing outliers. Next, transforming the data, converting it into a format that works well for the model. Finally, the structured data organized in a way that makes it easy for the model to learn from. Now, partitioning the data in Python. Now, let's talk about partitioning the data. We divide our datasets into two main parts: training data and testing data. The training data is what we use to teach the machine learning model and learns from its data to make predictions. The testing data, on the other hand, is kept separate. We use it to evaluate how well the model performs after it's been trained. Our next subtopic is balancing the training data set in Python. Sometimes your training data isn't balanced, meaning one category may have more, way more examples than the other one. This is a problem because the models might become biased toward the majority class. To fix this, we use balancing technique. Overslamping increase the number of examples in minority class by duplicating or creating new synthetic data. Understamping reduce the majority class by randomly removing some data. You can even combine both techniques to balance your dataset. Next is building cart decision tree using Python. Now let's dive into building decision trees. A popular algorithm for this is a CART, which stands for Classification and Regression Trees. This process is pretty straightforward. Step 1, we split the data into smaller subsets based on the different features like age or income. The goal is to make these subsets are similar as possible. Step 2, we create decision nodes that represent their splits. And step 3, we keep splitting until we reach leaf nodes. These are the final predictions made by the tree. Another type of decision tree is C5.0. It's similar to CART but has some key difference. CART uses Gini impurity to decide whether to split, while C5.0 uses information gain. C5.0 is also more robust to overfit, which means it can handle more complex data, while CART is a simpler and easy to interpret. C5.0 is a bit more complex but can work better in large datasets. Next in we have building random forest in Python. Let's take decision tree a step further by combining many trees into a random forest. This technique is called bagging or bootstrap aggregating. For this, we for this process we follow the some steps. Step 1, we create multiple decision trees, each trained on a random subset of the data. Step 2, each tree is also trained using a random subset of feature which help introduce variety. Step 3, once all the trees make their predictions, we combine them. This could be done through majority voting from classification problems or averaging for regressions. Next in we have evaluation model performance. After building the model, it is time for the evaluation how well it performs. There are several metrics we use to measure accuracy. Accuracy tells us the percentage of correct predictions. Precision measures how many of the predicted positive results were actually positive. Recall shows how many of actual positives were correctly identified. The F1 score balance predictions and recalls. It gives a single score to evaluate the model. Our next steps and conclusions could be once we have evaluated our model, it's time to fine tune it. This could involve adjusting the hyperparameters, trying different algorithms, or going back to the data preparation phase. It can iterative process, build, evaluate, or refine. Ultimately, the goal is to create a model that performs well and provide accurate predictions. The preparation of your data and the choice of model are crucial into this process. Thanks for watching. We covered the key steps in data preparation and model building using Python. Whether you are using decision trees, random forest, or other machine learning algorithms, remember that the data preparation phase is just as important as the model itself. Happy coding and good luck for your projects. Stay curious and keep learning.